5.2 linear functions. Quick review. So hopefully a lot of this will make sense because you've seen it before in Algebra 1 and geometry. So what makes a function linear? Well, a lot of people will say that, or they answer that question with the word slope. So linear functions have a slope. And it's not really wrong. That's definitely part of the answer. I would prefer to think of this as a linear function has a constant rate of change. So let's look at two tables. If I gave you this table, so 2, 3, 4, so the x's go up by ones, and those are my values there, and then the second table looks like this, also 2, 3, 4, and then we'll do 5, 3, and 0 again. Okay, so if I'm looking at those tables and I want to know if it's a linear function or not, I look at the changes in the x's versus the changes in the y's. So, for example, from 2 to 3 is plus 1, from 3 to 4 is plus 1. So I get the same over here. Both of these go up by ones. From 5 to 3 is minus 2, and from 3 to 1 is minus 2. So the rate of change, and the rate of change is usually done in this way. It is the change in y divided by the change in x. And so the rate of change for both of these is a negative 2 over 1, which is a negative 2, and the same thing for that one. It's a negative 2 over 1, which is a negative 2. So it's a constant rate of change. This is also the slope of the line. This is the slope of the straight line that goes through the point. So over here, from 5 to 3 is minus 2, from 3 to 0 is minus 3, and since these are over 1s, you can see that a negative 2 over 1 is a negative 2, which is not the same as a negative 3 over 1, which is a negative 3. So we do not have a constant rate of change. This is not going to be a linear function. In terms of pictures, linear functions are straight lines. So we talked about that before. Let's draw a straight line here. Let's say that we have a straight line like this. Let's make that 3. And we'll make this one 4. Okay, so where is your rate of change here? Well, the rate of change, or the slope, is still the change in y over the change in x. So if I go from this point here to that point over there, I can find the slope by finding what the changes in the y values. So the changes in the y values is we go from, so if we're on the x-axis, we need to go up 1, 2, 3, 4. So this is 4, and it's over 1, 2, 3. Okay, and up is always positive, so here the rate of change, which is the same as the slope, so the slope of this line would be up 4 over 3. If you're wondering how that connects to this thing, well, this is just what you do in terms of symbols, whereas what I'm doing is verbally just explaining what it is. So constant rate of change means take the y values of the second and subtract the y value of the first. We'll see if that works. So this point here would be 0, 4, and this point here would be a negative 3, 0. So do I get the same answer? So let's call this point 1. So this is point 1, and this is point 2. So it says y2, which is 4, minus y1, which is 0, divided by x2, which is 0, minus x1, so the x value on the first point is a negative 3, and minus a negative 3 ends up being plus 3, and so you get 4 over 3 as well. So it is all connected. Okay, linear functions can be both increasing and decreasing. Well, they can be increasing, decreasing, they can be constant as well. That would be a slope of 0. But most of the times we either deal with an increasing or a decreasing line. So right here, this line over here that I drew is an increasing line. So that one is increasing. Okay, increasing means, in terms of the slope or the rate of change, so slope, which is rate of change. So it's increasing if this is positive. It's decreasing then if this is a negative slope. And we saw the decreasing one right over here. That's an example of a decreasing function. Something didn't quite work out, but so this is an example of a decreasing function. How do you find intercepts? Well, intercepts we can usually find intercepts by plugging in zeros. So one time you use an x of 0 and then you solve for y. And the other time we're going to use y as 0 and you solve for x. And the reason that works is because if you look at any intercept, so this is a y-intercept, the x value is always going to be 0 on the y-axis. And the x-intercept, so this is a y-intercept, and the x-intercept, it can move along the x-axis, but the y value will always be 0. So you can find intercepts by plugging in 0 and solving for the other value. So for example, let's say I have y equals 2x minus 5. If I say x is 0, I will get y equals 2 times 0 minus 5. So that's 0 minus 5. So 0 minus 5 is a negative 5. So 0, negative 5 is the y-intercept. If I want to find the x-intercept, then you use y as 0. So 0 is 2x minus 5. You plug the 5 onto this side. So then you get x equals 5 over 2. So then 5 over 2, 0 is a point on the line, and that would be the x-intercept. Also want you to remember that this value here, remember that that represents the slope, and this value over here, that is the y-intercept. So you actually could have read the y-intercept off out of this equation, but notice that when we calculated it, we did get this same value back. We don't always get the linear functions in that form. Sometimes they look a little, little funky or a little different. So what about this one? This is still a linear function. Okay, another way that you can look at linear functions is that you have to, so it's a variable, it's a function that's defined in two variables, so one x and one y, and then they have to have a degree of 1 or an exponent of 1. So both of these are to the first power, so that makes it linear. So how do you find it here? Well, the same way. You can still say, well, let's make x 0. So you get 0 over 2 plus 3y is 6. So that means that 3y is 6, so y would be 6 over 3 is 2. So there's an intercept at 0, 2. Or you can say y is 0. So if y is 0, you would get x divided by 2 plus 3 times 0 is 6. So that means x over 2 is 6, so x must be 12. So there's an intercept at 12, 0 as well. So this is your x-intercept. And for this one, this is your y-intercept. Okay, notice that this function isn't giving me the intercept or the y-intercept by just looking at it. So this is, I don't really like people to just blanket say, hey, negative 5, that's your y-intercept, because here this is the number 6, and 6 wasn't an intercept. And this form also did not give me any information really about the slope. Okay, so why would we have this form? Well, it does have its other uses. So finding intercepts, for example, is pretty easy. Okay, so you might run into things like that. Alright, let's look at how do you find the equation of a line. So there are different ways of doing this, and I'm going to show you two very general forms. So we'll use y equals mx plus b, and we'll use that for this line that I'm going to call number 1. So for line number 1, I'm going to use y equals mx plus b. So that would be called the slope-intercept form of a line. So how can you do this? Well, I'm going to use my definition for slope, which is rate of change. So I know that there are 2 points here that are accurate, and I just want to know how much do I need to go up and how much do I need to go over. And I can do that better. how much up and how much over do I go? Well, from here I need to go up to 2, so this is 2, and from a negative 6 it's 1, 2, 3, 4, 5, 6 steps over here. So the rate of change is up, and the rate of change is the slope. It's up 2 over 6, so that's 1 over 3. So that allows you to fill in that point over here, or the value over there. So y equals 1/3 of x plus. And a moment ago, I circled this thing in the equation. It was a -5 and said, well, that's the y-intercept. Okay, so in this case, we do have a y-intercept. It's at 2, so I should be able to just plug in the 2 right in over there. And that's the correct equation for this line. The equation of this line is y equals 1/3 of x plus 2. Okay, well, sometimes you're going to be given a line where maybe you're just given 1 point and then an intercept, or just 2 points, but you're not given that y-intercept. So this method doesn't work really well for that. So what else can you do? Well, as long as you have 1 point and you can read off another one, you can use this formula, which is y minus y1 equals m times x minus x1. And this is called the point, because you need 1 point, slope form of a straight line. Okay, because you need 1 point. y1, x1 represents that 1 point, so we need x1 and y1. And I need to know the slope. Well, in this case, the slope again I can calculate. I need to figure out how much I go up, which is 4, and how much do I go over, which is 2. So the slope is up 4 over 2, which is 2. And then I can just plug in the point. So in this one, I'm going to say m is 2, and then the point, x1, y1, I'll just use the 2, -4 right there. So 2, -4. So what do we get? We get y minus y1, which is a -4, so that ends up being y plus 4 equals m, which is 2, times x minus x1, and x1 is 2. So that's the equation of the line. And you may leave that, okay? Some students don't like to leave this because they always want to write it, in this form. So how can you go from point slope to slope intercept? Well, just distribute and solve for y. So if you want to know what it would look like, you would say, well, 2 times x, and 2 times a -4. Subtract the 4 on both sides, so y equals 2x minus 8. Let's check that and see if that would make sense. So I know we can't get a bigger graph, but I can definitely continue, because 7 would be about there. And it appears that it would probably go through 8. But we can actually confirm that by using the slope. Because remember that I said constant rate of change. Well, constant rate of change means that if you go from one point to the next point by going up 4 over 2, then the next point over, again, should be up 4 over 2. And notice that we are back on the line. But you can also go backwards. You can go this way 2, and then we're actually right here on the axis, and then down 4. 1, 2, 3, 4. And notice that if you were at a -4, -5, -6, -7, -8, that is the correct y-intercept. So this is the right equation. You don't have to do that for me. You may leave the equation in this form. That saves you some time and some effort. Alright, and the last thing is then how do we graph straight lines? Well, that depends a lot on in what form it's given to you. So the intercept method, for example, works great for equations that are given to you like this. So what about 2x plus 3y equals 6? Well, you can use the intercept method here. You can say, well, if x is 0, then we get 2 times 0 is 0, plus 3y is 6, so 3y is 6 divided by 3, so y must be 2. So the point 0, 2 is on the line. You can do the same thing with y. So if y is 0, you get 2x plus 3 times 0 is 0, divided by 6, so that sort of cancels out. Divided by 6, you get 3 for your x, so that point is on the line. And then just graph it. So this line goes through those 2 points. And since a straight line is defined by any 2 points, because constant rate of change means if you go from one point to the next by doing this, then the same thing should happen on every other point. So 0, 2 is on there, and now I need to get to 3, 0. So if you go down to over 3. There's your next point. And every other point after that will be down to over 3 as well. So this is a good way to graph it if it's given to you in that kind of a form. Okay. Do need to caution here. Sometimes this breaks down a little bit. So what if I wrote 2x plus 3y equals 5? See, the problem that you run into now is that you get x 0. So you get 0 plus 3y. So you get 3y equals 5. So y equals 5 over 3. And we're not really supposed to graph fractions. Okay? So, and you get a fraction also for the x-intercept. So it's not a perfect method. But, you know, slope-intercept method isn't always perfect either. It depends on how it's given to you. So let's see what we have over here. So slope-intercept method works really well if the form of the linear equation is the slope-intercept form of the line. So here is an equation in slope-intercept form. Okay, so most of us know, well, that's the slope. And this is your y-intercept. So I have enough information to graph this line at this point. Okay, that line goes through the y-intercept of a -1. So that means it goes through this point over here. So the y-intercept occurring at a -1 is the point 0, -1. Then how do I use this slope? So, and the symbol for slope is m. So what does it mean to have a -1 over 3? So I'm going to put the negative always with the top. So -1, so this is the change in y over the change in x. That's the rate of change. So for the next y value, you need to go down 1 and over 1, 2, 3. So that point must be on the line. So then you just connect those two, and then you have a straight line for this. Okay, great method. Doesn't require a lot of work, and it gets you your values fairly easily. I'm going to do one more of those. So what if I said that the equation I wanted was y equals 2x minus 5. So how would you do that then? Well, again, that's your y-intercept. So you go to -5 on the y-axis. So 1, 2, 3, 4, 5. So there's a point here. So what does the 2 mean? Well, the 2 is the rate of change, but right now I don't have a comparison between the y's and the x's. So if you get a whole number, just write it as a fraction. So this means that you go up to, because it's positive, up to over 1. So if you read it this way, you always go to the right from your first point to your second point. And then you connect the 2 dots to finish this off. So this line would look a little like this. My scaling is off a little bit, so we'll keep it short. Okay. Okay, thanks.